Good morning, good afternoon, good evening, class. This is Mr. Arosena, and today we'll finish off function operations. We're talking about a new type of operation which we call a composition. Okay, this operation is different from addition, subtraction, multiplication, and division, as you will see shortly. Okay, so quick recap before we get any further. We talked about function addition, which I'll remind everybody that a function addition is just f of x plus g of x. Okay, that's a function addition. A function subtraction. Yeah, that's much better. Function subtraction is just f of x minus g of x. Okay. Function multiplication is f of x times g of x, which is sometimes written as f dot g of x, and I notice it's a closed dot. That'll become important in a moment. And then function division is just f of x divided by g of x, which is really just a rational function. So what we talked about the last couple of lessons. Today we'll be talking about a new function operation called a function composition. Oops. Hit the back too many times. Alright, so function composition looks like is defined as follows. When one function is substituted into another function. Okay, so let us think for a moment. Function composition is when we take one function and we substitute it into the other function. Okay, mechanically this basically means that we calculate the first function at some value of x. That'll give us some answer. That'll be the output. Okay, so the output from the first function is then put into the second function. Okay, so take one function, calculate it, take the resulting answer, and put it into the second function. So it's basically calculating one function followed by another function. Okay, and we can show this as a single operation. Okay, and we show that as follows, like this. F, and inside the function f, we put g of x. Okay, basically what this means is we're going to calculate g of x first. So calculate g of x first, and whatever result that gives you, put it into f of x. Okay. Now sometimes this is written as follows: f open circle g of x. Okay, so I like to call this fog of x. Okay, so a function composition is sometimes, I refer to it as fog of x, and because of this particular symbology there. Okay, but the idea is, again, you basically calculate whatever's inside. In this case, calculate g of x. Do that first, and then put the resulting answer inside f of x, and that will be the resulting answer for the whatever you're evaluating. Okay. All right, it'll become a little more clear, I think, once we go through a few examples. Okay, as it usually does. So let's go through some examples. All right, so here's an example. So given that g of x is equal to 3x and f of x is equal to 1 plus x, we're going to calculate the following functions. Or function compositions, I guess. The first is GOF, or g composed of f of 2. And the other one is f of g of negative 4. So let's start with the first one, GOF of x, or GOF of 2. Okay. So this, I usually don't leave it in this form. What I will do is instead I'll rewrite it like this. G, and inside g, I put f of x. Okay. And what this basically means, again, is that I'm going to calculate f of x first, because that's inside g. And in this case, because we know what is going to be f of 2, I'm going to calculate f at 2. Okay, so what is f of 2? F of 2 is equal to, well, f of x is 1 plus x, so this will become 1 plus 2, so f of 2 is 3. Okay, so then this function becomes g of 3, because f of 2 is really equal to 3, so I can replace f of 2 with 3. right? So f of 2 here, calculated by itself, it gets you 3. Then we can take 3 and put it back into g. Now g of 3 then just becomes, well, g of x is 3 times 3, or 3 times x, sorry. G of x is up there, 3 times x, so it becomes 3 times 3, which is then equal to 9. There we go. So that is what g open circle f of 2 is equal to 9. Okay. This g open circle f is more correctly referred to as g composed of f at 2. Okay. Right, let's try the next one. Here it's already written in the nice form where we have f and then we have g of negative 4 inside. So we'll calculate g of negative 4 first. G negative 4, that's equal to 3 times negative 4, which is equal to negative 12. And then we'll put the negative 12 into f. So negative 12, f of negative 12. This ends up becoming, I should stop using arrows, equals 1 plus negative 12. And this ends up giving me an answer of what's 1 plus negative 12? That is negative 11. There we go. There. So all we basically did was we calculated g of negative 4 first. That gave us an answer of negative 12. And once we got the answer of negative 12, we put that back into f, because that's really what g of negative 4 is, really just negative 12. So the problem becomes f of negative 12. And then we carried that calculation out using the function f of x equals 1 plus x. And that gives us our answer of negative 11. Right. So it's not so difficult. Just got to remind yourself that all you really got to do is calculate the inside function first. So calculate the inside function first, and then put that into the outside function, and then that'll be your resulting answer. All right. Now, functions, you can't compose functions with themselves, because what this basically means is basically you just calculate the answer of the function once, calculate the answer of the function, then put it back into the function to calculate another answer. Something like this usually actually happens quite a lot in biology. This is what you would consider a feedback loop in biology, where your body creates something and then it uses that something to either create more of it or create less of it, depending on whether you want a positive feedback loop or a negative feedback loop. Okay, so this is one application, I guess, of this, or one place you would see function compositions. Okay, so basically, this function depends on itself. Okay, so what this is saying is that the function f depends on itself at some point. Okay, and you don't treat this any differently than the previous example. You just basically calculate the answer from the first function, and then you just put it back into the function to get a second answer. Okay, and we'll illustrate that with another example. Okay. Okay, so here we go. So given the following, f of x equals 3x minus 1. Calculate what is f of x, and then what is f of f of x. That's that one. Alright, so let's start with the first one here. Oh, wait. This one's slightly different because we don't know what x is equal to. What are we going to do? This just really isn't all that difficult. Alright, so since we don't have an actual answer or actual value to calculate at x, we'll wholesale take this function and put it into here. Alright, so we're putting the 3x minus 1 into the function. It'll look like this. F of 3x minus 1. Right, now what do we do with this? Well, as with any function, if this were just a number, I would just put it back into the function. So let's do the exact same thing. We'll put the expression back into the function. So 3, and then we'll replace x with 3x minus 1. We'll have a minus 1 there. We can clean things up a bit, so we get 9x minus 3 minus 1, and final simplification, we'll get 9x minus 4. There we go. So this is what the function composed of itself is going to look like. So notice, even though we don't have a value for x, we can still compose the function. All we really did was we replaced f of x with the actual function itself, and then we put it into wherever x is supposed to go. So keep that in mind. If you're given a problem and it's asking you to calculate what is f of g of x, but doesn't give you a value for x, just take g of x and throw it into f of x. At whatever value of, or wherever x appears, replace it with g of x. Okay. Let's do the next example here. So here's f of f of x. Well, thankfully, we already know what f of x is, so we can replace this quantity with this quantity over here. And so all of this gets substituted into here. So now we get the following. It becomes f of 9x minus 4. Okay, and we do the exact same thing with the previous one. Well, we know f of x is just 3 times x, and we know in this case x is just going to be equal to this. So this becomes 3 times 9x minus 4 minus 1. Clean things up a bit. We get 27x minus 12 minus 1. Further clean up, 27x minus 13. There we go. This is what f of x is going to look like. Okay. So even though we don't know what value x is, we can still compose the function. We just have to use a little bit of algebra, I suppose, to help us out a bit. Okay. All right, let's go through another example. All right. So another one. So here we have two functions, f of x equals 1 over x, g of x equal to 3x plus 2. And again, much like the previous one we just did, this set of examples, we don't know what x is equal to. So we're going to have to basically just put one function inside another function. So here, g of x is equal to 3x plus 2. We don't really know what value it is, so we'll just leave it as 3x plus 2. We know f is 1 over x, but in this case, x is 3x plus 2, so we'll replace the x with a 3x plus 2. And this is what f of g of x is. Okay. And notice, like I said earlier, we're really just taking one function and inserting it into another function. Okay, so we've taken g of x and we've stuck it into f of x like that. Okay. Next example. So next one will go g of f of x. Okay. So to do this one, well, just write it the same way as before. We have g. We'll replace f of x with 1 over x as follows. And then we'll substitute 1 over x for all instances of x in g of x. So we get the following: 3 times x, but x is really 1 over x, and then plus 2. We can clean this up a bit, so we get 3 over x plus 2. There we go. And again here, all we really did was we took f of x, and we replaced x with f of x. Okay. That's really all you have to do with a function composition. Right? And other than that, you can treat it as any other type of function you've seen before, especially if you're trying to analyze it numerically. Okay. Alright, with that, you guys should be able to complete your assignment. I'll give the checklist to you. You guys should be getting the checklist as well, so that you know what you were supposed to do these last couple of lessons, and you'll be all set for your test. And if you guys have any questions, you know how to contact me.